Okay, I will read the question number 7. What is question number 7? Rain is falling vertically with a speed of 30 meters per second. This is the velocity of rain. Velocity of rain, and it is given as 30 meters per second. It is given as 30 meters per second. It's a vector, so I am showing the direction of that vector. And a woman rides a bicycle with a speed of 10 meters per second. Woman rides a bicycle with a speed of 10 meters per second in the north to south direction. In the north to south direction. Usually we are giving the direction like this. This is north, this is south, and this is east, west. Right? We are usually giving the directions like this. But let's see. In this case, they are saying north to south direction. North to south direction. So I am taking note this convention. If I am taking this convention, I will be confused because the rain is perpendicular to the map. If this is a map, rain is perpendicular to that map. The directions are marked on this map. The directions are marked on this map. So I am not using this convention. I am not using this convention. Okay. So I am taking another convention here. I will show you that convention. This is like this. The woman is riding her bicycle like this. Woman is riding her bicycle like this. This is from north to south. North to south. So this is south and this is north. Okay, north to south. And the speed is given as 10 meters per second. Speed is given as 10 meters per second. I can take that velocity of woman as a vector, and its value is 10 meters per second. So I got the figure right. I got the figure. Okay. Now, what is the relative velocity of rain with respect to woman? What is relative velocity of rain? You can call it as relative velocity of rain with respect to women. VRW. What is VRW? That is the first question. What is VRW? That is the first question. What is VRW? What is the second question? What is the direction in which she should hold her umbrella to protect herself from rain? What should be the direction of holding the umbrella to protect herself from the rain? That is the second question. What direction? What direction? What direction should she hold the umbrella to protect herself from the rain? So that's the second question. How can we answer this one? How can we answer this one? Just look here. What is this? This is two vectors, two velocity vectors. You know velocity vectors are free vectors. You can displace them, right? You can displace them. And this is velocity vector of woman. Velocity of woman. That is in the direction of south, north to south. If this is north and it is north to south. Okay. And this is what? This is velocity vector of rain. It is velocity vector of rain. It is acting downward direction. It is acting in downward direction. So I want to find VRW. What is VRW? Velocity of rain with respect to velocity of woman. Velocity of woman. How we can do that? That will be the resultant of both these vectors. That will be the resultant of these vectors. That will be the resultant of these vectors. Okay. So how we can do this one? How we can do this one? Velocity of rain with respect to woman. Velocity of rain with respect to woman. I will show you how to do that. I can extend this vector like this, right? I can extend the vector like this. The woman is going that direction, rain is going in this direction. So I am extending this vector. So this vector will be VR. This vector is a free vector, that's why I can do this one. This is VR, vector VR. Okay. Now this is vector VR and this is velocity vector of woman. Velocity vector of woman. If I am finding the resultant here, if I am finding the resultant here, that will be between VW and VR. That will be between VW and VR. But what will be the problem? I will get the direction like this. I will get the direction like this. Okay. So this is the direction of ray, and if I am taking the opposite vector like this, if I am taking the opposite vector of velocity of woman like this, you can call it as VW. You can call it as minus VW. You can call it as minus VW. Then what will be the direction of the vector here? The resultant vector will be in this direction, because I can find the resultant vector like this. I will show you to find the resultant vector, and this will be extending like this. If I am extending it, I will get a rectangle. I will get a rectangle, and a rectangle is a parallelogram. A rectangle is a parallelogram. You know that, right? Sneha, you told me you in the previous class you show me this question. Do you remember that? This is the question we are doing now. Okay. So this is the velocity vector of ray, and this is the velocity vector of woman, but in opposite direction. So you have to take it as minus VR, minus VW, minus VW. Okay. Now, what will be the resultant here? What will be the resultant? The resultant will be the diagonal of the parallelogram. It will be like this. Resultant will be the diagonal of the parallelogram. It will be like this. So this resultant will be VRW. What is this resultant? That will be VRW. Because if you get a resultant like this, you have to hold the umbrella like this. Woman is going in that direction. Rain is coming downward direction. So the resultant velocity of rain will be like this. So she should have to place the umbrella like this. She should have to place the umbrella like this in that direction. In that direction. Okay. Let's see how we can do that. If this is VRW, and you can write VR and VW. What will be VR? What is vector VR? Vector VR is the velocity vector of rain, and it is acting downward direction. It is acting downward direction. So downward direction is negative y-axis. Downward direction is negative y-axis. So the unit vector with this velocity vector will be minus j. The unit vector with this velocity vector will be minus j. So you can take it as 30 minus 30j. Minus 30j, or 30 minus j. 30 minus j is minus 30j. This is velocity vector of rain. This is velocity vector of rain. Now, what is velocity vector of woman? What is velocity vector of woman but negative? Velocity vector of woman is 10 I cap. It is in positive x direction, but I am taking in opposite direction. I am taking the velocity vector of women in opposite direction. So I can give the negative here. So VW, velocity vector of women, will be minus 10 I cap. Minus 10 I cap. Now what is this VRW? What is this VRW? What is VRW? VRW is the velocity of rain with respect to woman. Velocity of rain with respect to woman. Velocity of rain with respect to woman. What is that? That will be VRW. How you can find VRW? You can add both these vectors. You can add both these vectors. VR plus minus VW. VR plus minus VW. What is VR? VR is minus 30J. That is minus 30J. Okay. What is minus VW? Minus VW will be minus 10 I cap. That is VRW. That is VRW. That will be VRW. Okay. I will write it here. Now, what is VRW? Velocity of rain with respect to women. What is that? Velocity of rain with respect to women. velocity of rain with respect to women will be minus 10 I cap minus 30 J cap. This is the velocity of rain with respect to women. Minus 10 I cap minus 30 J cap meter per second. Meter per second. This is the velocity, relative velocity. This is the relative velocity of rain with respect to women. Relative velocity of rain with respect to women. That's VR. Okay. So we have found the first answer, and we have to see what direction. We have to see what direction. What direction should she put the umbrella? That's what we have to see now. So this is VRW. So the velocity of rain with respect to woman is in this direction. So she has to put the umbrella in the opposite direction like this. In the opposite direction like this. So she has to put the umbrella in the opposite direction like this. And this will be, I will draw the umbrella here. This should be the position of the umbrella. In order to protect her from the rain, this should be the position of the umbrella. And what will be that angle? What will be that angle? If you are getting an angle here like this, theta, and that will be the same angle between VRW and VR, because they are opposite angles, right? They are opposite angles. So if I am taking the angle with the vertical as theta, the theta will be the opposite angle to theta will be the opposite angle, and that angle is between VRW and VR. Okay, now I just need to find what is theta. What is theta? This is VW. That's a velocity, but its magnitude will be equal to magnitude of VW. And this length is equal to the magnitude of VR. It is equal to the magnitude of VR. So theta has an opposite side. Theta has an opposite side of minus VW here and VR here. Okay. If you find tan theta, you will get the direction. What will be tan theta from this figure? What will be tan theta from this figure? Tan theta from this figure will be opposite side divided by adjacent side. Who is the opposite side of theta? VW is the opposite side of theta. So VW divided by adjacent side of theta will be VR. Adjacent side of theta will be VR. You will get tan theta. Now what is tan theta? Tan theta is VW divided by VR. What is VW? VW is 10. VW is 10 divided by VR. What is VR? VR is 30 meter per second. So 10 divided by 30. That's tan theta. That is tan theta. Or tan theta is equal to 1 by 3. Tan theta is equal to 1 by 3. Then what is theta? What is theta? Theta will be tan inverse of 1 by 3. Theta will be tan inverse of 1 by 3. Tan inverse of 1 by 3. Did you get it? Theta will be tan inverse of 1 by 3. Tan inverse of 1 by 3. Then that way, you will find the value of theta. Okay? And this is not a standard value. Tan inverse of 1 by 3 is not a standard value, and it should be given in the question. Or it is not given in the question, this will be your answer. Okay? I have written the value of tan inverse 1 by 3, and tan inverse 1 by 3 is tan inverse 1 by 3 is 18 degree. 18 degree. You don't have to study that by heart because that is not a standard value. It should be given in the question. Okay? So theta is equal to what? Tan inverse 1 by 3, and tan inverse 1 by 3 is 18 degree. 18 degree. It is roughly 18 degree. If theta is 18 degree, that means it is 18 degree like this. It will be like here also. Here also it is 18 degree. So the woman should put the umbrella 18 degree from the vertical towards the south. Did you understand that? woman should put the umbrella or hold the umbrella from vertical with an angle 18 degrees towards the south. That will be the direction to hold the umbrella. That should be the direction to hold the umbrella. This is our question. This is our solution. I know this is a little bit confusing. Maybe in the first part. Just take the note. I will repeat it. I will repeat it. Okay? Have you taken the note? Have you taken the note? I will explain again this solution. Let me know if you have completed it. Are you finished? Arpita, Sneha, Jaden, Joshua, Sana, Shikha.
Yes, sir.
Then I will repeat the question and the solution. Repeat the question and solution. What is it? This is question number 7. Question is like this. Rain is falling vertically with a speed of 30 meters per second. So this is the direction of rain and it is having a velocity 30 meters per second. Okay. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. In the north to south direction. I am taking north here and south here. Okay. In the north to south direction. So the woman's velocity is written as VW and that velocity is 10 meters per second. That velocity is 10 meters per second in the north to south direction. What is the relative velocity of rain with respect to women? That is the question. What is the relative velocity of rain with respect to women? What is the relative velocity of rain with respect to women? How we can do that? You can extend this velocity vector in downward direction. You can extend the velocity vector of rain. So now VR is the extension of that velocity vector. VR is the extension of that velocity vector. And you have to show the velocity vector of woman. This is in x direction, positive x direction. If you are taking the negative of it, you will get minus VW. That will be in negative x direction. In negative x direction. This is the negative vector of VW. Negative vector of VW. Why we are doing this? Why we are doing this? If you are finding the resultant like this, if you are finding the resultant like this, then the direction of umbrella should be like this. That is not okay. That is not correct. Okay. So you have to take the negative vector of VW and it will be minus VW like this. Okay. If you are finding the resultant, that will be like this. This is a parallelogram now. So you can find the resultant like this. that resultant will be VRW. And what is VRW? VRW is the velocity of train with respect to moment. How you can find that? This is VR. How you can find VR? VR is given in the question as 30 meter per second downward. Downward. 30 downward. Downward is minus J. Downward is minus J. So you have to write that vector as minus 30J. And velocity of woman. Velocity of woman is in positive x direction, but I am taking the negative vector of it. So that will be in negative x direction. To show it a vector in negative x direction, I have to give minus I. I have to give minus I. So minus VW will be minus 10I cap. If you want to find the resultant vector, you can add them. You have to add the vectors. If I am adding the vectors, VR, that's the first vector, minus VW, that is the second vector, add them. If you are adding them, you will get minus 30J minus 10I. If you are writing it, it will be like this. VRW will be minus 10I minus 30J meter per second. That will be the velocity of rain with respect to woman. Okay? And you need to find in which direction the woman should hold the umbrella. Okay? How you can find that? If this is theta, there will be an opposite theta here. In that direction, she should hold the umbrella. To find theta, you can use tan theta. What is tan theta? Opposite side by adjacent side. This is opposite side VW. That's opposite side VW. What is the adjacent side? That is VR. I'm just taking the magnitude only. Then that will be 10 divided by 30. 10 divided by 30, 1 by 3. What is tan theta? Tan theta is 1 by 3. If you want theta, that will be tan inverse of 1 by 3. Tan inverse of 1 by 3. And it is 18 degrees. If you don't know the value of tan inverse of 1 by 3, you can just write it as tan inverse 1 by 3. No. So theta is 18 degree and she should hold the umbrella 18 degree to the vertical towards south. Okay, that's the final answer. The woman should hold the umbrella, should hold the umbrella 18 degree umbrella from vertical, 18 degree from vertical, 18 degree from vertical, 18 degree from vertical towards south, towards south. Is that okay? Take that note also. Take that note also. I told you to get the examples of vectors, every problems that is going to ask in this chapter will be an example for the vector analysis, vector calculations. This is a vector calculation. It's a vector calculation. And it is a practical example also. Practical example of vectors also. Can I move to the next question?
Yes, sir.
Yeah. Then we are going to see the next question. The next question, that is question 8. Question number 8. That's a similar question actually. Question number 8. A river 800 meter wide flows at the rate of 5 kilometers per hour. So I am showing a river here. This is the top view of a river. What is this? I am seeing the river from the top. This is the top view of a river. And the river is 800-meter wide. So it is 800-meter wide. It is like this, 800-meter wide. 800 meter is the width of the river. Okay. And one man, it is flowing in the speed with in a speed of 5 kilometers per hour. It is flowing in a speed of 5 kilometers per hour. I am just showing that velocity here. I am just showing that velocity here. What is that velocity? Velocity of river. Velocity of river is a vector, and velocity of river, I am imagining the river is flowing in that direction. So velocity of river is 5 kilometers per hour. Velocity of river is 5 kilometers per hour. That is the velocity of river. In the north to south direction. In the north to south direction. In the north to south direction. I am imagining this as north, then the opposite side will be southward. So this is north to south direction. Okay, all the others will be changed accordingly. I am taking this as north and this as south. This is my convention. We can draw it in this direction, no problem. If you are doing this in like this, if you are drawing this figure like this, then now north will be up, south will be down. All the direction, other directions will be accordingly. Okay, I am taking north here and south here. Okay, it is flowing from north to south. Flowing from north to south. A swimmer. No, it is not given in north to south. That's from the other question. Okay, that's from the other question. And the next line. A swimmer who can swim at 10 kilometers per hour in still water. There is a swimmer and he can swim at 10 kilometers per hour in still water. That's his speed. That is his speed. I am taking it as velocity of swimmer. Velocity of swimmer. What is velocity of swimmer? That's 10 kilometers per hour in still water. That's his speed. Wishes to cross the river straight. He wants to cross the river straight. He wants to cross the river. He needs to get from this point to this point. Right? He needs to get from this point to this point. How he can do that? If he is swimming like this, if he is swimming like this, there is a flow of river. There is a flow of water, and that flow will turn him like this. That flow will turn him like this. Then his direction will be like this. His direction will be like this, right? If he wants to cross the river, he needs to swim in the opposite direction. Can you understand that? If the swimmer wants to cross the river, he needs to swim in the opposite direction. He needs to swim in the opposite direction. I will show you that direction. He needs what? He needs to cross the river. I am showing that with a dotted line. He needs to cross the river. Okay, he needs to cross the river. For that, he needs to swim in the opposite direction. He needs to swim in the opposite direction like this. So I can take that as Vs, vector Vs. What is that? Vector Vs, and its magnitude is 10 kilometers per hour. Vector Vs, velocity of swimmer. That is velocity of swimmer. You got it? This is the two vectors you have, Vr and Vs. What is that? Vr and Vs. And you should understand something. There must be an angle. There must be an angle with this displacement line. There must be an angle with this displacement line. I am taking that angle as theta. If I am taking that angle as theta, then you can split this velocity vector of swimmer into two. You can split this velocity vector. One vector will be here. One vector will be here. The other vector will be in this direction. So I am drawing that in separate color. One vector will be in this direction. One vector will be in this direction. This must be the direction of one component of Vs. Other component of Vs will be in the opposite direction, like this. Okay. Now this Vs is the velocity vector of the swimmer, that is split into two vectors. Vs is the velocity vector of the swimmer. You can split that into two vectors. What are those vectors? This is the vector or the component which is close to theta. Which is the component close to theta? Component close to theta is Vs cos theta. This is Vs cos theta. Component close to theta is Vs cos theta. And component far from theta is Vs sin theta. Vs sin theta. And you have two vectors now. V are in that direction and Vs sin theta in opposite direction. So you can equate them. You can equate these two vectors because they are in opposite directions. They are in opposite directions. And what is Vs sin theta now? Vs sin theta is now equal to Vr. Vs sin theta is now equal to Vr. Did you understand that? Vs sin theta is now equal to Vr. You got it? Did you understand up to this point?
Yes, sir.
Okay. And what is Vr? Vr is 5 km per hour. What is Vs? Vs is 10 km per hour. So Vs is 10. 10 into sine theta is equal to Vr. What is Vr? Vr is 5. Okay. Vr is 5. Now you will get sine theta from here. What is sine theta? There is already 5 here. You can bring this 10 to the other side. Then 5 divided by 10. You will get 5 divided by 10. That is sine theta. Sine theta is equal to 5 divided by 10. And what is that? 5 divided by 10. That will be 1 by 2. So sine theta is equal to 1 by 2. Sine theta is equal to 1 by 2. Then what is theta? What is value of theta? Theta will be sine inverse of 1 by 2. Theta will be sine inverse of 1 by 2. What is the value sine inverse of 1 by 2? Tell me what is the value sine inverse of 1 by 2? Whose sine of angle is 1 by 2? Which angle will give you the value 1 by 2 if you are putting that in sine? Which angle will give you 1 by 2 if you are putting that with the sine function? Sine of which angle is 1 by 2? That is the question. That is sine inverse. Sine of which angle is 1 by 2?
Sine 30.
30, yeah. Yes. Then sine inverse 1 by 2 will be 30. Sine inverse 1 by 2 will be 30 degree. Okay? Sine inverse 1 by 2 will be 30 degree. So we get the angle. Angle is 30 degree. We get the angle. Angle is 30 degree. Now look at the question. Along what direction must he strike? Along what direction must he strike? He should strike with the angle 30 degree. Right? He should strike with the angle 30 degree. That is the first question. That is the first question. He should strike with the angle. He should strike with. He should strike with an angle. With an angle 30 degree. He should strike with an angle 30 degree. That is the first question. And what is the second one? What is the second question? What should be his resultant velocity? That's the question. What should be his resultant velocity? resultant velocity of swimmer. Resultant velocity of swimmer. Resultant velocity of swimmer. Resultant velocity of swimmer. Can you give me the resultant velocity of swimmer from the figure? Not the value, just the name only. There is Vs cos theta, Vs sin theta, Vr, Vs. 4 velocities you can see in the board. In which of these velocity will give you the resultant velocity of swimmer? Which of these velocity will give you the resultant velocity of swimmer? Resultant velocity of swimmer. Which velocity among these will give you resultant velocity of swimmer? Which velocity? Is it Vr? Is it Vr? Please answer me, guys. Is it Vr? Vr will give you the resultant velocity of swimmer. Is this the velocity of swimmer? Answer me, please. Is it the velocity of swimmer? Vr?
Yes.
No, Vr is the velocity of river. Okay? And Vs is the velocity of swimmer, but not his resultant velocity. Okay? Resultant velocity is the velocity he can experience. Resultant velocity is the velocity he can experience. He can provide this velocity Vs, but he will not get that velocity. The velocity he can experience will be the resultant of Vr and Vs. In this figure, what velocity is the resultant of Vr and Vs? Which velocity is the resultant velocity of Vr and Vs from this figure? From this figure. Just look at this figure, guys. Look at this figure. This is Vr and Vs. Now you can imagine Vr and Vs as two sides of a parallelogram. Two sides of a parallelogram. Then you can complete that parallelogram like this. This is now a parallelogram. And the diagonal will be the resultant. The diagonal will be the resultant. So this green component is the resultant. I will give it another color. This red color, you can see this. You can see this, right? That red color component is the resultant now. Okay? That's the resultant. This is the resultant now. This vector will be the resultant. This vector will be the resultant between Vr and Vs. Vr and Vs. That's evident from the figure. So resultant velocity of swimmer will be Vs cos theta. Resultant velocity of swimmer will be Vs cos theta. Vs cos theta. I am just taking the magnitude only. Vs cos theta. What is Vs? Vs is 10. So 10 into cos theta. Cos theta. What is theta? Theta is 30. And what is the value of cos theta? Cos 30. What is the value of cos 30? Sin 30 is 1 by 2. What is the value of cos 30? Cos 30. Cos 30 is root 3 by 2. Okay? Sin 30 is 1 by 2. Cos 30 is root 3 by 2. You should keep that in mind. Right? Cos 30 is root 3 by 2. That will not be given in the question. You have to remember that. Cos 30 is root 3 by 2. So 10 into root 3 by 2. And now this 10 and 2 is gone. What you will get? That will be 5 into root 3. 5 into root 3. 5 root 3. That is the velocity. That is the resultant velocity. 5 root 3 meter per second. Sorry, that is not meter per second. That will be in kilometer per hour. Kilometer per hour. Because I have converted it. That's it. 5 root 3. And you can find the final value. What is the value of root 3? What is root 3? Root 3 is roughly 1.7. Root 3 is 1.7. 1.707 to be exact. I can take it as 1.7. Then what is 1.7 into 5? That will be 8.5. So